All right, today we're going to review solving linear equations. So we got a couple vocab we're going to go through first. First off, we're going to have the solution of an equation is the value of the variables that make the equation a true statement. So we end up with something like 2 equals 2, 4 equals 4. We just want to figure out, okay, what does that letter, what does the variable have to equal to make the statement true? So when solving this, our goal is to get the variable by itself. So get variable by itself. To do this, we need to do the opposite operation. So do the opposite of what is currently in the equation. So the opposite of addition would be subtraction. Opposite of multiplication is division. And then there's 3 different types of scenarios we could have. We can have equations with one variable can have one solution, they can have no solution, or they can have infinite solutions. Okay. So with this, we have our 3 scenarios down here. When we have one solution, we have only one value will make the statement true, so one number. Will it be true? Sometimes. So a conditional equation is true for some of the values of x. I'm just going to get down here into the solving it. If we go ahead and solve this, 4x plus 6 equals 18. You go ahead and subtract 6 from each side, so that's the opposite there. We're left with 4x equaling 12. And then from there, we divide each side by 4. We're going to end up with x equaling 3 as our answer. Okay, for the middle one, we're looking at infinitely many solutions. So with this, we can plug in any value for the letter. So any value for x, any value for whatever letter it may be, and we will always get a true statement. So I'm going to go ahead and skip the second row again. So on this one, we split it left-right. I have x's on each side, so I need to get them to one side first. So I'm going to subtract 5x from the right, 5x from the left, and we are left with 15 equaling 15. When the letters go away, you go ahead and have like alarms going off in your head. You say, okay, we do not have x equaling a number. We just have 2 numbers there. If it is a true statement, so in this case 15 equals 15, we go ahead and say, yes, we have infinite solutions. Our third scenario is the no solution, and this is when no values can be plugged in to make the equation true. Again, letters on each side, so you subtract 4x from each side. We're left with 8 equaling 3. Again, all the letters are gone, so you have alarms going off in your head. You ask yourself, hey, does 8 equal 3? In this case, it is a false statement, so since 8 does not equal 3, we say that there is no solution for that equation. Okay, on the back, we're going to look at some more difficult problems. So the distributive property is going to be when you're multiplying inside the parentheses, order of operations, PEMDAS, and then combine like terms. I'm just going to go ahead and work through these examples down here. So what I always like to do is draw a line through the middle, equal sign. Goal is to get our letters to one side, numbers to the other. So here I got to move the plus 7 over by subtracting 7 from each side. End up with 3x equals 3. Last step, divide each side by 3. And we are left with x equaling 1. Moving on, I'm going to skip this. I'm going to go to 3, the third one. Whenever you have parentheses, you have 2 options here. You can either distribute in or divide each side by 3. I'm going to go ahead and distribute the 3 in to get 6x minus 9 equals 12. From there, to get x by itself, you're going to go ahead and add 9 to each side. So we get 6x equals 21. And then from there, divide each side by 6. We're going to get x equals 21/6. Whenever you end up with a fraction like this, you want to make sure that's simplified. So simplifying this, you can divide top and bottom by 3. Doing that is going to give me 7/2 as our answer. All right, there's only a couple more I want to do. Let's go ahead and do this one in the middle here. Distribute, again, when you have parentheses, so the 13 goes in, giving me 26x minus 13. That equals 26x minus 13. From there, get your letters to one side. So if I subtract 26x from each side, I'm left with negative 13 equals negative 13. This is a scenario again where when the letters are gone, you have to ask yourself, does it make sense? In this case, letters are gone. Negative 13 does equal negative 13, so we are going to have infinite solutions. All right, and then the last one I'm going to look at is going to be this one, the bottom middle. Again, parentheses, you go ahead and multiply in. So I'm left with 10x plus 8 minus 11 equals 4x. Distribute the 3 in, so plus 6x minus 3. Left-hand side, you have 10x minus 3. Right-hand side, 10x minus 3. So we always distribute. From there, combine your like terms. And then again, when I look at this, getting my letters to one side, I subtract 10x from each side, and I'm left with a negative 3 equaling negative 3. Remember, when letters are gone, so when I come across a problem where all the variables go away, I'm just left with a number equaling a number. If that number equals the number, so if they're the same on each side, we have infinite solutions. If these were two different numbers, then we would have no solution. Okay, so when the letters are gone, we ask, is the statement true? If it is, it's infinite solutions. If it's not, it's no solution.